All right, here we have the first AP problem in the Unit 5 review packet. And with this one, we are calculator active. So I've got my TI-89 ready to go. First thing I want to do is graph the function 8 minus x to the 3 halves, the x-axis and the y-axis. So we're talking about this enclosed region right here. And so to find the area, what we need to do is just integrate the given function. Let's see, a is going to be the integral of 8 minus x to the 3 halves dx, and then you need to know the limits of integration. And the first limit of integration is 0 because the y-axis is one of our limits of integration. Then to find the other limit, it looks to be 4 just from looking at it, but I don't want to just rely on the graph, so let me just look at my algebra. If I plug in a 4 for x, square root it to 2, cube it to 8, I do have 8 minus 8 equals 0. So I have confirmed that this is 4. Now, since we have a calculator for this guy, we are allowed to do our integration on the calculator. So I'm going to do that. Just do the integral of 8 minus x raised to the 3 halves with respect to x, so comma x, comma 0, comma 4, and I get 96/5, which if I feel like switching it to a decimal to know that it's 19.2. Now, for the AP exam and for the test, all you have to do is show the setup. Don't forget the dx. If you want to get really picky, put in your parentheses there, and then your limits of integration and the answer. So part B says, find the volume when you generate, or find the volume of the solid generated when r is revolved around the x-axis. So we're going to have the constant pi, same limits of integration, and then just to remind you, since this graph is adjacent to the axis of revolution, which is the x-axis, we could use the disk method. So all we have to do here is square. We have to square 8 minus x to the 3 halves and multiply that integral by pi. So let's go back to our home screen, and I'm going to actually use the integral that I already had, but I'm going to modify it to take 8 minus x to the 3 halves, put it in parentheses, and square it. Same limits of integration we already had, and I'm going to multiply the entire expression by pi. And let's just make sure we have the integral of 8 minus 3 halves all squared, then the whole integral times pi, and we get 576 pi over 5, which is in fact the correct answer. And again, to get full credit on the AP exam, you need to show the entire integral setup, including the constant pi, the limits of integration, and then show your answer. Part C says, the vertical line x minus k divides the region. So let me just sketch that region. That region looked like this. So we're going to have some vertical line that divides this so that when the regions are revolved around the x-axis, they create equal volumes. So we've got some line here, x equals k. What that means is that we're going to set up equal integrals, one from 0 to k, and remember we're revolving this around the x-axis. So we still have 8 minus 3 halves squared, and we're going to set this integral from 0 to k equal to an integral from k to 4. Again, 8 minus x to the 3 halves all squared dx. So then they want us to find the value of k. So that will be interesting. I think first thing I'm going to do when I plug this into my calculator, I'm going to ignore the pi's because those will cancel out. I'm going to go back to my calculator and I think I'm going to go back up to, well, I'm going to use exactly what I have here. I'm going to base my work on the 8 minus x to the 3 halves all squared with respect to x from 0 to 4, but instead of 4, I'm going to plug in the value alpha k. So that is my first expression. So do you see how that is 8 minus x to the 3 halves all squared from 0 to k? Now my second expression that I need is going to be from k to 4. So let's switch my limits of integration to k and 4. And if you notice, I'm finding that expression. I now have both of my expressions logged into my calculator, and I haven't even started the solve key. If you try to put in one line solve and these two expressions, you're probably going to make some sort of input error that will make it difficult for you to resolve. So if you do each section separately, it's a lot easier to deal with, a lot easier to find your mistakes inputting into the calculator. So now we have F2 solve, and what I want to do is take the integral from 0 to k, and I want to set it equal to the integral from k to 4, and I want to solve for k. So alpha k, close paren, and hit enter. And let's see how long this takes. Could take a minute. Okay, I actually hit pause and walked away and let my calculator do the thinking and came back, and I finally have an answer of k equals 0.994 or 0.995. So once again, to get full credit for this problem, you have to show the complete setup and the answer, but your calculator can do the work for you.